Hey there, and welcome. Today we're going to talk about one of the coolest, most powerful, and kind of mind-bending ideas in all of physics, quantum interference.
So, let's start with a little thought experiment. Imagine you're trying to solve a maze, a ridiculously complex one. Now, instead of trying every single path, one by one, what if you could explore all of them at the exact same time? And then, get this, what if some universal rule just made every single dead end, poof, disappear? It sounds like magic, but that's pretty much what quantum interference does. It's the universe's ultimate cheat code.
You know, at its core, interference is something you've seen a million times. Just think about ripples in a pond. When two waves meet up, their peaks can add together to make an even bigger wave, right? That's called constructive interference. But if a peak meets a trough, they cancel each other out and the water goes flat. That's destructive interference. Quantum mechanics just takes that super simple idea and applies it to, well, everything.
To really see what I mean, let's check out our first big example. This is where that simple ripple effect becomes the most precise ruler in the entire universe, a ruler that can measure the pull of gravity with just staggering accuracy.
You know, figuring out gravity is an ancient quest. For almost 2,000 years, everyone just went with Aristotle's idea that heavier things fall faster. Makes sense, right? But then came Galileo, then Newton, and finally Einstein, who completely changed the game. But every step forward needed better and better experiments to test these huge ideas, especially that fundamental one, that in a vacuum, a hammer and a feather really do fall at the exact same rate.
So how do you take Einstein's incredible theories and push them even further today? Well, you need to measure gravity's pull more precisely than anyone has ever done before. You basically need a ruler that's so unbelievably sensitive it can spot the tiniest changes. And it turns out, the best ruler for the job is built out of atoms. And you guessed it, interference.
Okay, so check out how this incredible experiment at Stanford works. First, they take a cloud of atoms, chill them to almost absolute zero, and then launch them straight up a 10-meter tower. Then, a laser pulse does something that sounds like sci-fi. It actually splits the quantum wave of each atom, sending it down two different paths at the same time. The two atom waves travel up, then fall back down, and then a final laser pulse brings them back together so they can interfere with each other.
And this is where the magic happens. Because those two paths were slightly different, they each felt Earth's gravity just a little bit differently. So when they come back together, they create an interference pattern, just like those ripples in the pond. And by simply looking at that pattern, scientists can measure the pull of gravity with mind-boggling precision.
And when I say precision, I mean it. The sensitivity they reached was 6.7 times 10 to the minus 12 G. To put that in perspective, that's 100 times better than any previous attempt. It's a level of accuracy it's almost impossible to wrap your head around. And it's all thanks to making atoms behave like waves.
But what I love about this story is that behind all this insane science, you find these incredibly creative, real people. In her dissertation, the lead scientist, Dr. Susanna Dickerson, credits inspiration from hiking, from scuba diving, from pure imagination. It's just such a great reminder that science isn't just numbers and labs. It's a deeply human thing, fueled by curiosity, and apparently sometimes by really good recipes for chocolate cake and cheesecake.
Okay, so let's switch gears. We've seen how we can use interference to measure the physical world. Now let's see how that exact same principle is powering a totally different kind of revolution, this time in computing.
To get this, you gotta understand the basic building blocks. A regular computer bit is super simple, right? It's either a 0 or a 1. That's it. But a quantum bit, or qubit, is where things get weird. It can be a 0, a 1, or both at the exact same time. That's a property called superposition. And it's this ability to be in multiple states at once that opens the door for interference to happen inside a computer.
So here's the quantum magic trick. A quantum computer starts by putting all the possible answers to a problem into this massive superposition. Think of it like a giant orchestra, where every instrument is playing a different potential answer. The quantum algorithm then acts like a conductor. It uses constructive interference to make the sound of the correct answer get louder and louder and louder. At the same time, it uses destructive interference to tell all the wrong answers to quiet down until they've all faded away to nothing.
Now, why is this such a game changer? Well, because this trick lets quantum computers solve problems that are just flat out impossible for even the world's biggest supercomputers. We're talking about designing new life-saving drugs, inventing revolutionary materials, optimizing global supply chains, and, yes, even breaking the kind of encryption that protects most of our digital world today. So let's just pause and take a step back here.
We've looked at two completely different worlds, right? One is about measuring the physical universe around us. The other is about navigating this abstract world of data. And yet, both of them are running on the exact same quantum secret sauce.
Let's just put them side by side. You've got atom interferometry, which uses real, physical atoms to do ridiculously precise measurements. Then you have quantum computing, using these abstract qubits to do incredibly powerful calculations. The goals are different, the tools are different, but the engine is identical. Interference. One uses it to find a tiny true signal in all the noise of the universe, the other uses it to make all the noise of the wrong answers just vanish.
I mean, it's just amazing when you think about it. It shows you the incredible power of one single, fundamental rule of nature. The very same principle that lets us test Einstein's ideas about gravity is the same one that could revolutionize medicine, finance, AI, everything. It's just a beautiful example of how understanding one deep truth about the universe can unlock technologies you never would have imagined. And that kind of brings us to the big final thought. We are really just at the beginning of learning how to speak this quantum language and use its power. It's already reshaping our world, from how we see the cosmos to how we might solve our biggest problems. Which really only leaves one question, doesn't it? What on earth are we going to build with it next?